How are you, my dear students? I hope everyone okay. In the previous class, we have also explained about the art and the gravitation. Here's the art and the gravitation, the chapter 7. We have also explained about the mass and weight and the relation between mass and weight. And the mass and weight, actually, it's also the interesting topics, I hope, and you have also learned it accurately. Today, I have just selected the lesson 6 and the lesson. Here's the lesson 7 and 8. Here's the lesson 6. Here's also the explain structure. Basically, the acceleration due to gravity and the weight of an object are different at different places on the earth. Now, please everyone open the books and the page number 75. Here's the weight of an object depends on the acceleration due to gravity g. Here's also I will write this. The g is equal to basically g, or the gravitation equal to g into m divided by d square. It's also the hypothesis also. And the reason for which the value of g, small g, changes are also the reasons for which the weight of an object changes. Now, the weight of an object is not an invariant quantity. Its value changes from places to the place on earth. The reasons for which the weight of an object changes are described below. First category is the A. Basically, A is the at different places on the surface of the earth. The weight of an object is different at different locations on the earth because of the shape of the earth and its different locations. Second is for the shape of the earth. Since the earth is not a perfect sphere, all points on the surface of the earth are not at equal distance from the center of the earth. As the value of g, basically for the center of the earth, is also the center of the earth, and for the as the value of g is also the value of g is at a point depends on its distance from the center of the earth. Here's also the distance is also the center of the earth, and the value of g becomes different in different places on the earth's surface. At the equatorial area, the radius of the earth is largest and the value of g is lowest. Basically, lowest is the 9.78. Here's the 9.78 meter per second square. Here's also the another I also explained in the previous class. Yes, the 9.78 the meter per second square. There. This is why weight of an object is minimum in this region. As we move from the equator of the poles, the radius of the earth decreases and the value of g increases. The radius of the earth is the decreases and the value of g is the increases. Here's also the decreases structure and the increases structure is the basically 9.83 meter per second square. This is also the another structure. Again, because of this, weight of an object is also increases. At the pole of the radius of the pole is minimum and the value of small g is maximum. The pole is the minimum and g, small g, is the maximum. As a result, the weight of an object is highest in this region. 2. For the diurnal rotation of the earth. Because of the diurnal rotation of the earth, the acceleration due to gravity gradually increases from the equatorial region to polar region. As a result, the weight of an object also increases as we move from the equatorial region to polar region. B. For the increase of height from the earth's surface. As we soar to higher heights, the value of the acceleration due to gravity decreases. Because of the greater height from the surface of the earth, the lower is the value of the weight of an object. Thus, the value of g is less at the top of a mountain. Hence, the g is the value of the top of the mountain. C. At a point inside the earth, basically at a point, here's also the inside the earth, As we go deeper inside the earth, the value of the acceleration due to gravity goes on decreasing. Because of this, the weight of an object goes on decreasing as we go deeper and deeper inside the earth. Thus, the weight of an object is less inside a mind. At the center of the earth, the value of the acceleration due to gravity is 0. Therefore, if we take an object to the center of the earth, there will be no force of attraction of the earth on the object and its weight will be 0. It's also the another hints and also the another topics. If as we go deeper inside the earth, the value of the acceleration due to gravity goes on decreasing. This is also the another point. Now I have also selected the last topics 7 and 8, lesson 7 and 8. The variation of weight in lift and in space weightlessness. The value of g, basically the value of a small g is a particular at a particular point on the surface of the earth is fixed, and therefore the weight of a person at that point is also definite. But even then a person there may feel a change of this weight and even feel weightlessness under special conditions. To understand the change of weight and weightlessness in a lift, we have to introduce the idea of inertial frame of difference and the concept of apparent weight. When a system of reference moves with constant velocity, it is called an inertial system. Thus, an inertial system has no acceleration. Newton's laws are applicable only in inertial systems. In an accelerated frame, the apparent weight of a body differs from the true weight. Whenever a frame of reference is accelerated, an inertial force arises from which we can find the apparent weight. If the frame like our lift has an acceleration a, an inertial fictitious force arises given by minus ma in a direction opposite of the acceleration of the frame of reference. By applying Newton's law of motion, basically Newton's law is equal to, I also write this structure, basically F plus minus mg is equal to ma, or F is equal to m, here's also the m, and normal structure is the g plus a. Acceleration a positive when lift is accelerated upwards and the felt weight of the person in the lift is greater than the real weight. If the lift is given additional acceleration downwards, the apparent weight felt is less than the real weight mg. If the lift has a free fall, then A is equal to G plus A is equal to G and F is equal to 0. Therefore, the apparent weight is 0 and the mass in the lift will feel weightlessness. An object released from the hand will remain static. If the lift is static or moving with a constant velocity, the mass in the lift will feel the normal weight. My dear students, actually it's also the headline is the earth and the gravitation. It's also the very important topics for your exam, the junior JC exam. Again, I also repeat which is the basically concept. One concept also the explain gravitation. Second concept, the explain the distinction between the gravitation and the gravity. Third is the explain the acceleration due to the gravity. Fourth is the distinguish between mass and weight. Again, I also explain the distinguish between mass and weight. Explain the change of weight of an object due to the influence of gravitational acceleration. When is the impact of gravitational acceleration in our life? And our lesson first one is the gravitation and the very important topics, the Newton's law of gravitation and the gravitational force. Lesson 2 and 3, the gravity and the acceleration due to the gravity. Third is also the very important topics, the variation of the acceleration due to the gravity. And lesson 4 is the mass and weight. Here we also explain the mass and also the weight. Here's also the weight basically. Again I also replay. Here's also the weight of an object with mass 10 kilogram is the 98 Newton. Here's also the variation, basically the mass and the weight. And we also select the today the acceleration due to the gravity and the weight of an object are different at different places on the earth. Here we also explain basically G is equal to Gm divided by d square. And also the lift is also the another reaction. This structure is the Newton's law. I hope everyone is understand from this structure and also from these the topics, the earth and the gravitation. So I have just also closed this chapter today. Thank you, my dear students.